So let me divide the room in two pieces, right? You're the networking people, networking and security people. All you care about is NFV, virtualizing your network functions, your security functions. And today you're tipping your toes into automation a little bit, right? But networking, security, virtualization is top of mind. On this side, I have the developers. You're into cloud, you're into DevOps, CI/CD pipelines. All you care about is speed. Get your applications out there very quickly in the order of hours or even minutes, right? The edge is where you guys come together. In the edge, we will see applications living side by side with network functions, right? And what we want to do is we want not only give you guys speed, but also security so that you can quickly, when you deploy new applications, quickly deploy security functions in front of it at the same speed as you deploy your applications. And you guys are dipping your toes into the automation world. We want to give you the exact same tools that we're giving these people to make it fast and make you go faster as well. And that is exactly what I'm going to talk about in this presentation. Now, we've all heard about 5G, right? There's a lot of things that 5G enable us to do, and I'm not going to spend too much time on introductions. But 5G is kind of an enabler for many of the edge compute use cases in the sense that it not only gives us higher bandwidth, but it also gives us much lower latency. It gives us the ability to connect many, many more devices to the network as was previously possible. And as such, it really opens up a wide array of new use cases. Now, as F5 as a company, we are actually building solutions for you guys, for developers. We are building solutions for you guys, networking, guys and girls, sorry, networking and security people. And from our experience in the enterprise world, we obviously see all these companies going through digital transformation projects, right? They're moving into DevOps, cloud. They're bringing digital technology into every aspect of their business operations. But what we also see is that some things they cannot solve on their own. They will need service providers to provide some capabilities that they can't provide on their own. And 5G, and specifically edge computing, are actually enablers that will allow service providers to enter new business opportunities to deliver on those digital transformation projects that we see in the enterprise. So let's take a diagram of how networks look like, right? In the middle, you see the service provider data center, or it could be the POP, or whatever you call that. And if we would be sitting here 3 years ago, we would all be talking about NFV infrastructure, network functions sitting on top of that. And the people on this side of the room, the developers and the application teams, they would sit in another conference talking about private cloud, public cloud, what have you, completely separate from one another. So here you have your network functions on your NFV infrastructure, you have your applications on your private cloud environment. What we see happening, or what we've seen happening over the last, I would say, 1.5 to 2 years, is that applications are obviously moving to public cloud, some applications at least. And that is true for enterprises, that is true for service providers as well, right? Some of your internal apps, you're moving to the public cloud because it makes economic sense to do so. More recently, we start to see network functions move to public cloud as well. An example here could be an IMS solution, it could be a virtual EPC solution for an IoT use case that doesn't require high bandwidth processing, but a lot of control plane processing. Those use cases kind of make sense to deploy in public clouds as well. And it's slowly starting to happen, as we see in some cases. But that's not what we're going to talk about today, right? What we're going to talk about is going to the left-hand side, going to the edge compute closer to the end user, in the case of radio, closer to the base station, etc. This is where you can start deploying IoT applications. This is where you can start deploying virtual CDNs, etc. And if you deploy an application very distributed, you will have to move the network functions with it, because the network function has to happen right before you hit the application, right? You need a kind of breakout for your local traffic to access local applications. That's why both network functions and applications will move to the edge at the same time. So let's take 2 examples. Use case number 1, low latency for self-driving cars. Just checking, because the blue, I was hoping it would appear nicely. So here is a use case. Let's say that this is a very popular one. Self-driving cars, you need low latency, right? 5G technology is perfectly suited for that. If you host the application that is processing all the data from the car in a very centralized location like a public cloud, you have 40 millisecond end-to-end latency. That simply does not work for that use case, right? It's just too slow. What if we start distributing the network functions? We have this whole edge compute architecture and we move all these functions around. If you just move the network function in the edge, but you keep the application where it sits, for that application you haven't solved anything because the end-to-end latency is still 40 milliseconds. You may have different reasons to distribute your network functions because it could be cost efficient or whatever, but for this use case, you have not solved anything. So ultimately what you will need to do is you will need to move those network functions. This could be the S gateway, the P gateway in a mobile network to terminate the GTP tunnels and get native IP traffic into the application. You need to get the application moved into the edge compute side as well. And now you get 10 millisecond latency, now you have business value. This is what you need from a technical perspective to make this use case work. Let's take another one. I'm just taking two as an example, right? Virtualized CDN. What is the use case without CDN? Use case without CDN is you have an application server somewhere, a video server, which is serving video requests from end users. Let's say there is 100 views for this particular video. Everything gets streamed from a public cloud or from whatever content provider into your data center. You stream it over your backhaul and access network to the end user. So you require a lot of bandwidth from an end-to-end perspective. I would say this is not really happening too much anymore. The typical deployment model is where you have a third-party CDN hosted in your own data center. You have Akamai there, you have Netflix there, you have Google caches there, and typically you will even allow them to connect for free because you save a lot on transit costs by doing so. However, and this is something that we start to see more and more, many service providers are starting to think that they should look into building their own CDN for, one, their own content. Many of them are offering quad-play services. Yeah, with the explosion of video traffic, this will save you not only on the transit cost, but also on the backhaul cost. Don't forget, if you start deploying edge sites, this can be many, right? I mean, I know edge means different things to different people, but some service providers are thinking about thousands of these edge sites. That's a lot of capacity that you need to roll out, right? So any capacity you can gain is definitely a winner. So virtual CDNs, we see it as a driver even sometimes for MEC use cases to deploy this at the edge, primarily for their own content, but possibly also for local content. Of course, this is not a replacement for an Akamai or any other player in that space because it's not a worldwide CDN, but for some local content players, it could actually be a very beneficial model as well. So these were just two examples, right? So there's new business opportunities for service providers because they can start building new services on their own for the consumer market, for the enterprise market. There's a few examples here. I'm not going to read them all out. But at the same time, it's also a business opportunity to sell to enterprises and to allow them to host their applications in your edge compute site. And there's different models for that. You can do purely bare metal, where you just allow them access to your edge compute site. They put in their own hardware and they manage everything on their own. So for you, that is just providing space and connectivity, that's it. But I think more and more service providers are looking into building their own infrastructure and then offering an infrastructure as a service or a platform as a service capability on top of that. And that makes a lot of sense, right? So back to where I started, right? On the left-hand side here, you have the distributed VNFs and all the networking. They want a secure and virtualized networking stack. On the other hand, if you start opening up this edge compute architecture to third parties where they can host and bring their own applications and manage their own applications, they will want tools that make them fast because that's how they work. They're not going to accept the slowness that sometimes happens in our industry, right? So they want that speed. So how about an edge stack that gives everyone speed and security? And now everyone says, yeah. At least the F5 people. Anyway, so this is the common edge compute stack, right? You have network functions, virtual EPC, virtual GI LAN capabilities to do whatever traffic processing that you require in that space. And next to that, you have all these local applications, your virtual CDN, living side by side. Obviously, if third parties are going to consume an IaaS service or a PaaS service from you, you will need to have secure API management because you're going to deliver an API to third parties from that platform into your own infrastructure. So that is kind of a tricky thing to do, and it's something that needs to be very tightly secured. The recipe to do all this is obviously automation, right? And this is just a definition that I picked up from a website. It's all about using software to create repeatable instructions and processes, replacing or reducing human intervention, right? Avoid as much as possible human intervention. I gave the example of applications, how they spin up new applications on an hourly or even in order of minutes. There's no way you're going to do that manually, right? It's never going to work. For networking, it's the exact same thing, right? We use the exact same processes. When we speak to networking people or when we speak to application people, at the end of the day, when it's cloud or NFV, they talk about the same thing. They use different terminology, but at the end of the day, it is the same thing. And it was encouraging to hear, I mean, I was in the KPN session, which was 2 or 3 sessions before me, and they also said that they're bringing together the IT teams and the NFV teams, making sure they learn from each other and build a common framework for that. So how do you automate application services in the cloud? So this is for the developer people. So if you want, let's say, load balancing or other ADC services in front of an application, when they deploy an application, how do you automate this thing? First step is bootstrap. This is about bringing the virtual machine, in this case it's a F5 technology that provides these ADC functions. It's a virtual machine, virtual edition as we call it. You load it into your cloud of choice. This could be public cloud, private cloud, it doesn't matter. That is always a very specific template which is specific to the environment. So for Amazon, it's different than for an OpenStack or for a VMware environment, right? The next step is what we call onboarding. This is giving it IP addresses, a DNS server, a license so that it can do whatever it's supposed to do. It's really making it ready to get the configuration of what you want it to do, all the steps that are needed. We use a declarative API for that. And I'll come back to what that means because that's a very important concept. Next step is deploy the app services. What you want load balancing, you want layer 7 routing, you want web application firewalling. We deploy that again using a declarative API. Once it's deployed, we start monitoring, generating analytics, and then based on that analytics and based on policies that you have defined, we may have a feedback loop to change things. So we give all these tools to these developers, and they use whatever tools they use for their application deployments and CI/CD pipelines. We allow them to plug that in, right? So that's how they run their business. If you now go to NFV, it's the exact same thing. You deploy the VE, you onboard it. You don't deploy a load balancing service or a WAF service. No, you deploy a TCP optimization, a carrier-grade NAT, a GI firewall, a DNS service, whatever it is. Then we get analytics. And again, based on the analytics and the performance monitoring that we do, we might have to automatically scale out, scale in, and we have that feedback loop again. Exact same process. Are they using tools like Jenkins and Spinnaker and Terraform and what have you? No, they use VNF Manager typically for that. The VNF Manager is actually packaging these things in a product that most of the vendors sell. Now, some of them do use things like Ansible, etc. So not everybody using VNF Manager. So there is a bit of variation there in the industry. But you can see that conceptually, we're doing the exact same thing here. So, and that brings me to what we would call a unified automation framework, right? Where regardless of whether you have application services for your application, network functions for your NFV environment, you use the exact same methodology and the exact same tools and APIs to deliver these capabilities in a secure and a fast way. Let me go back to declarative versus imperative, and I apologize for becoming a little bit technical, but it's a very important concept for automation. An imperative API is what most vendors have, which is API calls to configure a service step by step. You tell the system how to configure a service. Take a firewall as an example. A firewall, you first create address lists, then these address lists, you use them in firewall rules. Then these firewall rules, you group them together into a firewall policy, and then you assign a firewall policy to an interface or whatever it is. These are different steps, different REST API calls that you need to go through in a specific sequence, otherwise it fails, in order to configure a service. If you bring that into an automation tool, it means that your automation tool needs to have the knowledge of how that service is built. It needs to know what to do when you fail somewhere halfway doing that configuration. There's a lot of complexity to program into your automation. Complexity means cost. A declarative API, on the other hand, it tells the system what you want. It tells the system what is the desired end state. So with one single, in this case, usually it's a JSON file, you give all the parameters of what you need the service to look like. You give it to the system with one single REST API command, and the outcome is either it succeeded and you have deployed the service, or it has failed completely, but then nothing has been done on the system. This means that you don't need any intelligence at all in your automation systems. That intelligence stays within the systems that you're configuring, and that is really critical to bring the cost down of automation, because automation always looks very nice on paper and you can do wonderful things with it, but it's a very costly process with imperative APIs. So you define the desired end state, and it is really imperative, that's a bit funny word here, to make automation cost efficient. So how does this final picture look like then? So now, we started with edge, but what I'm just explained really spans across the board, and some people call it a distributed telco cloud, and it goes from your central data center all the way into your far edge. But ultimately, you can even span it further into public cloud, because most of the mechanisms I explained are actually working in public cloud environments as well. Declarative definitions of capabilities, whether that's a GI firewall service, a carrier-grade NAT service, a web application firewall policy, these declarative definitions you can store in a repository like GitHub, as an example. You don't have to do this, but you could. And people can store it there. And what happens then is you have both declarations for network functions, you have declarations for application services for the applications. On the right-hand side here, the DevOps teams, they use their CI/CD tools. They pull the declarative definitions out of GitHub, and they push them into whatever environment you want these services to be configured. Typically, this goes hand in hand with the application deployment itself, obviously, right? This is not a standalone deployment. It's when you deploy the application or a new version of the application, you provide that capability. So in this case, in the far edge, you have an application which just requires an ADC function. In the central data center and the public cloud, you have an application which requires a WAF function. The VNF manager, on the other hand, this could be F5, it could be a generic VNF manager. And as I said earlier, some service providers are actually standardizing even on Ansible to do some of this. Perfectly fine. We're using the same tools here. They pull their declarative definitions from that same source code, and they push them where they need to be, at the edge compute site or at the central data center. So as you can see, these both worlds come together in the edge, and ultimately you can use the same capabilities and the same tools to provide these things. That's why we believe the edge is the place where people start to look into a common edge stack. As a summary, what we try to do is we try to make you faster, because we give you a common automation framework to deploy your apps and the application services in front of it, as well as the network functions from the NFV perspective. We make you smarter By that declarative API, we significantly simplify the integration with automation tools, and that ultimately leads to cost reduction, which we know is a big pain point for most service providers. And last but not least, we make you safer, because we give networking security to the networking people, and we give application security to the application people using the same concepts. And with that, I would like to thank you very much for your attention.